This is part 4 of the Unit 2 review for Honors Chemistry. Counting sig figs. 2 and 3 count the zeros to the right of a non-zero number, and I see a visibly drawn decimal, which means it counts. So 3 sig figs. Problem 2, 1.400, 1 to 4 count. Both of these zeros are on the right-hand side of the 4, and I see a drawn decimal point. So these both count, making this 4 sig figs. 4.8 both count. For scientific notation, we don't care about the times 10 portion, 2 sig figs. And then the 60,000, 6 counts. All 4 of these zeros are on the right hand side of a 6, and I see a drawn decimal point, so all of these count. Scientific notation. We need to move our decimals. There's only one place value to the left of the decimal, 9.81. We know it's going to be times 10 to a power of something. I move this decimal 3 spots, 4 spots. And then since this was a small number, I need my times 10 portion to be small, so that's negative. Move my decimal 3.6 times 10 to a power of something. Here's 3 spaces, there's 6 spaces. Since this was a big number, my times 10 portion needs to also be big. Go in the opposite direction, 3.2. I'm multiplying by a small number, so I need to make this number smaller. Move my decimal 1 space for a total of 3, so I need to add 2 zeros. Leading zero is nice, not needed, but it's nice to have there. Multiplying by a big number, so I need to make this larger. Moving my decimal 2 spots to the right gives me 542. Part B here, this is a calculated problem. We're not aiming for you to show your work. A couple ways to solve this, but I'm going to just do it straight in the calculator. Clear my memory here. 4, second key E, negative 2, caret 3, times 5, second key E, 10 to the 4th, caret 3. Remember when we use the EE key, it only shows one E, and also it takes place at the whole times 10 portion of a scientific notation number. Divide by, and here's the important part, my parentheses. 5, second key E to the 4th, caret 3, times 5, second key E, 4th, caret 2. Close my parentheses. Have to throw those parentheses around the whole bottom so I don't have an error. And the calculator gives me 2.56 times 10 to the negative 14th. If I look at sig figs, this has 2, this has 3, 3, 2. My answer can have 2.6 times 10 to the negative 14th. Additionally, one thing you may notice is that these are the same on the top and the bottom, so they can go away. So you can simplify your problem and just do this term and this whole term. Problem solving, density problems. What is the density? So that's what we're trying to find out about. Given these values, we have a diameter, we have a height, which is also known as a length, and we also have a mass. So we need to get a volume of the cylinder. V is going to be equal to pi r squared times height. So I'm going to use my pi key in my calculator. I'm going to use 1.8 centimeters as my diameter, but I need to divide that by 2 to get to a radius. I need to square that times the height, which is also known as a length. Sometimes we write it that way. 3.68 centimeters equals, the calculator gives us 9.3644 centimeters cubed. if I were to need to answer this volume right now, I'd have to look at sig figs. There are 3 here, there are 3 here, so we get 3 in our answer. So I'm going to just recognize that my volume should have 3 sig figs. I'm not going to actually round now though, because we don't want to introduce rounding error in the middle of the problem. Recall that density is equal to mass over volume. So the mass of this cylinder is 76.840 grams. The volume we just calculated at 9.3644. We're going to keep that number in the calculator. Again, not rounded. So as many digits as are in the calculator we're going to keep. We don't have to write them all here. We're going to keep them. And remember, this only has 3 sig figs. The calculated value of the density is 8.2054. We get 3 sig figs in our answer because our volume has 3, which comes from right here. 1, 2, 3 place values. 5 is trailing the 0. It's not a lone 5 because there's a 4 after it. So that equals 8.21 grams per centimeter cubed. Box that answer, so it's easy to find. A metal object in a graduated cylinder with an original water level of this is VI, initial volume. After the object is in there, it's VF. What is the density, it's a question mark, of the metal object if its mass is this? So again, we're trying to find a density, but we need a volume of our object first. The object was VF, that's VI. So 42.88 milliliters minus the 16.08 milliliters is going to be 26.80 milliliters or centimeters cubed, since this is a metal object. If I were to answer this, I'd have to think about place values. And this goes to the hundreds, this goes to the hundreds, so my answer can go to hundreds, which gives me 4 sig figs here. But we're looking for density. So we're just going to use the unrounded version, which this number doesn't happen to have, the rounded versus unrounded. But it's important to remember we don't use rounded values in the middle of calculations. So D is equal to 3.8298. You get 4 sig figs for my volume. The mass has 5. So we're going to change this 9, because it's followed by an 8, into a 10, which increases the 2 up to a 3. That's grams per centimeter cubed. Box that answer. Now, again, milliliters minus milliliters should give us milliliters, but we can transfer those mils to centimeters cubed because they're equivalent. 1 milliliter equals 1 centimeter cubed. And since it's a solid object, we want to use the grams per centimeters cubed density unit. Problem number 3 requires that we measure the side of a cube. So you will actually measure this with a ruler, and we want to keep those place values in mind. So putting a ruler and measuring carefully gets you to a value of 1.87 centimeters. Since this is a cube, we can assume that all the sides are the same, which means the volume of the cube is equal to a side cubed. So 1.87 centimeters cubed gives me a value of 6.54 centimeters cubed. It's important to show your work on this problem. Cube density would be the mass divided by the volume, since the mass is given to us as 127.19 grams divided by 6.54. 4 centimeters cubed, I get a number of 19.5 grams per centimeter cubed. That's the rounded value coming from 3 sig figs in my volume. 19.5, if I match those up over here, is closest to that of gold, so the identity of the cube must be gold. However, my actual measured value compared to the true value isn't the same, so I need to do my percent error calculation. 19.5 minus 19.30. So observed, the one that I measured, minus the true value divided by the true value times 100. The thing we have to remember on these calculations is that we have to do the addition subtraction first. So 19.5 minus 19.30 gives me 0.2 as a difference. And I can report to here because the 19.5 goes to tenths, 30 goes to hundredths. 0.2 divided by 19.3 times 100 gives me this value. But looking back at sig figs, I have a 1 digit divided by a 3 digit, or 4 digit, excuse me. So then I get to have 1 digit in my answer. This would be a 1% error. Recall that percent errors can be negative or positive. It's okay if they're negative. Recall also that one thing that's important to do is to measure to the hundredths when we're using a centimeter ruler. This will be something that I'm looking for when I grade exams for that problem.